everyone, in today's video we will be talking about the color of stars, thermal emitters, and temperature scales. So when we think about thermal emitters, it's anything that can release heat or emit radiation. So a thermal emitter, prime example, would be the sun. Why are hot stars blue and cold stars red? We normally associate the color red with hot and the color blue with cold. And why is that? Maybe that's a general perception that our society thinks, but let me explain why hot stars are actually blue. So, in thermal emitters, hot is actually emitting shorter wavelength radiation, as we talked about in the last video when we mentioned about the electromagnetic spectrum, and we said that violet emits shorter frequency and radiation, which turns out to be more energy than red color, and emits longer wavelengths and turns out to be less energy. Wavelength radiation. And cold is just the direct opposite, in which we emit longer wavelength radiation. So which one do you think provides more energy? Always remember that the hot objects will emit shorter wavelengths and a higher frequency than colder objects, which emit longer wavelengths and shorter frequency. But you might ask, ice is cold and it's blue. Coals are also red, and why is this contradicting in this case? Well, coals are actually red because they glow best in the infrared radiation. And in the infrared section, we see orange and red colors. And for ice, they actually reflect the blue light best, and so that is why we see them as blue colors. So always remember, hot equals blue, and cold stars, in this case, is red. So now let's talk about stars and transition our way into temperature scales. When we talk about the star's surface temperature, we're measuring the wavelength at which the spectrum peaks, or the color of the star. So if the wavelength is peaking at 780, we would see the star at a reddish color, and we can measure the temperature that way. And we can also define a star to be a black body. So what is a black body? A black body is an idealized physical body that can absorb all incident heat radiation or electromagnetic radiation. And that is very important in stars that we are talking about in astronomy and all other objects. So last but not least, we're going to move on to temperature scales. In this section, we're going to cover the conversions of Celsius to Fahrenheit and Celsius to Kelvin. So how do we convert Celsius to Kelvin? What's the equation for that? And it's actually K equals C plus 273. So if we have this equation, in order to figure out, let's say we have a certain number for Kelvin, we just subtract negative 273, minus it to the other side, and we get Celsius. And then if we want to get Kelvin, you add 273. The other equation that we need to know for Fahrenheit is F equals to 9/5 times the Celsius plus 32. So in order to get Fahrenheit, you have to use this equation. And let's say we want to get Celsius, then we can just do F minus 32. And once we subtract it to the other side, we can actually divide by 9/5, and that would turn out to be 5/9 times the Fahrenheit minus 32 equals the Celsius. So these equations are the conversions that you need to know to convert from Kelvin, Fahrenheit, and Celsius. Thank you for watching this episode. In the next one, we're going to cover Wien's law, Stefan Boltzmann's law, and the luminosity.